Good morning, everyone. I welcome you all for this course, Engineering Geology, CE8392. Today, we are going to see about remote sensing and its application in civil engineering. Let me introduce myself. I am P. Nirmal, working as an assistant professor in the Department of Civil Engineering, Government College of Engineering, Dharmaburi. First, let us see the definition of remote sensing. Remote sensing is defined as an art and science of obtaining an information about an object or a feature without any physical contact with it. And remote sensing can be used to measure variation in acoustic wave distribution, variation in force distribution, and variation in electromagnetic distribution. The principle of remote sensing is that remote sensing uses electromagnetic wave energy for obtaining information about an object. When the light consists of electromagnetic wave of different wavelength and intensity. When the light falls on an object, it is partially observed, scattered, transmitted, and reflected. Each object has a different property of observing, scattering, transmitting, and reflecting energy. By detecting and measuring the electromagnetic energy from the reflected object, we can identify or categorize an object. Usually, it depends upon the property of the target material and the incident energy, we can identify the information about the project. Stages in the remote sensing is that source A will emit the electromagnetic radiation. It will incident on the target C. Then C reflects some amount of electromagnetic radiation which is picked up by the sensor at E. The sensor will transmit the gathered information to the ground station. There, the information is converted into a digital one or images. From the images, the information about an object is interpreted. Usually, the data obtained from the satellite are transferred to the ground station through radars, where the user analyze and find out the types of object and information about it. This whole process is called image processing. The element of image processing include identifying the color of an object, size, shape and texture of the object, territory and pattern and height, site and its association. These elements will help in identifying the projects. There are two types of satellites are available. First one is geostationary satellites and then polar orbital satellites. As the name suggests, geostationary means this satellite fixed at a particular position and gather the information about an Earth. The polar operation satellite, it will rotate about or move about the poles and gather the information about an Earth. GIS. GIS we know it is an geographical information system. It is a computer tool for input, storage, management, retrieval, and output of an information. The information in the GIS are usually related to the characteristics of geological information or an area. GIS provides a tool for creating, managing, analyzing, and visualizing the data associated with the developing and managing the infrastructures. Some of the applications of remote sensing are resource exploration, town planning, urban development, irrigation management, watershed management, groundwater studies, and natural hazard studies. First one is resource exploration. Remote sensing helps the geologists to study the formation of the sedimentary rocks in the earth surfaces, and also it helps in identifying the minerals available on the earth crust without any physical contact with the earth. It also detects the oil fields, water storage in the undergrounds. Remote sensing is also helpful in identifying the potential fishing zones, coral relief mapping in ocean technology. Site investigation. Remote sensing is used extensively in site investigation for dams, bridges, and pipelines. Usually, the site investigation generally required topographical and geological consideration. Remote sensing permits such assessment. In case of dam investigation, geological consideration like types of soil, rocks, and physical properties are essential. So, the remote sensing helps in identifying the types of soil, which will helps the engineer to identify the site. In case of bridges, the main important consideration is the stability of slopes. We don't know where the soaring will occur, but remote sensing based on the history of soil erosion and sedimentation, it will helps in predicting the hazardous zone and helps in site investigation. Next one is town planning. Remote sensing data is very important when it comes to infrastructure management. It will help you to make a decision on how to upgrade, build, or arrange your work. So they helps in developing a plant preparation, infrastructure planning, and environmental trainings. The development plan preparation include infrastructure networks such as it helps in aligning loads, railways, settlements in the area, and hydrological features such as rivers and lakes, the present usage of land and geological level landscapes. It also helps in developing the master plan of an town and also helps in town planning. Infrastructure planning includes road alignment, road network and road connectivity, and utility planning such as sewage treatment plant, garbage land disposals, water works, and growth in the center locations. Environmental planning, it includes usually the unprecedented growth of urbanization in India has given rise to problem of housing, sanitation, power supply, disposal, etc. But the remote sensing helps us to monitor the urban uses and helps in proper planning of the management and making policies. Irrigation management. The remote sensing help in the assessment of water availability in the reservoir for optimal management of water to meet the irrigation demand. It also helps in identifying the assessment of the irrigated crops and the water requirement for each crops. It also distinguishes the surface water body and groundwater body in a particular irrigated land. It also helps in identifying the crop yield and study on the waterlogging sanitary problems in the irrigated land. Watershed management. Usually, watershed management includes estimation of the physiographic parameters that can be obtained from the remote sense data, including watershed area, size, shape, topography, drainage pattern, and landform. It also helps in identifying the hydrological and meteorological variables such as rain and runoff in a particular area. The hydrological process such as precipitation and evapotranspiration are generally used as an input for stimulating a model which helps in predicting runoff and groundwater flow. Groundwater study includes the estimation of the geomorphological parameter essential for groundwater modeling. Groundwater modeling is a model which helps in identifying the flow of the water in undergrounds. It also helps in estimation of the groundwater potential and storage capacity of the area. Natural hazard study. Remote sensing helps us in predicting the natural hazards such as earthquake, volcano, landslides before it occurs. So it helps the disaster management group to do the necessary step in minimizing the hazards.